Hello everyone, this is Sam from HiPy. Today we're going to be looking at interacting with web APIs for Python. But first, don't leave yet if you're not interested in that. We're going to be looking at something extremely important in Python, and it's how we can use Anaconda to install and manage the packages and libraries that we have installed. So if we are on the Anaconda Navigator, we click this environments button, we'll come up with this horrible list of long list of modules, and then if we click on this drop down menu and then we click on all, we will see that we're not even like scratched the surface of all the libraries that we can install. There are tons that are uninstalled, and the reason why we don't install these straight away is because all of these, when you install a Python library, it takes a little bit of weight on the kind of kernel, which is kind of like the behind the scenes operating system of Python, and it means that if we installed all of these straight away, it would just be a nightmare. We wouldn't be able to run anything very quickly. So Anaconda lets us pick and choose what we want to do. It selects some very common ones to start off with. We have kind of bokeh, which is one that we use for interactive visualizations. There's a cryptography kind of library for codes and whatever, so they're all quite useful, but there are some that are not installed which we will want to install. So if you go to install to all and then you search for pandas, you will see that there are a lot of kind of different things here. This won't be ticked for you, but we're going to do that in a minute. And there's one for kind of interacting with SQL databases. There's kind of Blaze, which is for big data, so huge data tables. We want to be using Blaze instead of Pandas for the most part. But the one we're interested in today is Pandas Data Reader. So it lets us interact with certain web APIs, download the data to Python, and then be able to interact with it straight away. So if you click on this box, there'll be a little apply thing that appears down here. You click on this, it installs all the prerequisites, it does everything for you. I'm not going to do that here because I want to keep this video as short as possible. And then when you're done with that, you can go to the Anaconda or back to your Jupyter notebook. If you're in Azure notebooks, it's slightly different. I think you have to do !pip install pandas data reader. It might not be that. I think it is, but if that doesn't work, check the FAQ because there's some subtle differences between the two. So we're going to be looking at creating a stock graph for a stock symbol, essentially. So we're going to be looking at a stock kind of symbol like Apple, AAPL, and we're going to be downloading the stock data from that. We're going to be kind of taking it from one date to the other, and we're just going to be graphing that very simply. The thing to take away from this one is that web APIs exist, and we want to know how to kind of get some very basic data off them and just provide an example. So I should explain myself here a little bit better. An API is like a waiter in that we tell the API what data we want. The API will then contact the server, get the data, and then bring it back to us. So we are going to be using the Google Finance API, which means that the data we're going to be getting back is stock data, and then we're going to tell Google what symbol and then the start and end date of the data, and then it's going to say, oh, okay, I know what data you want now. He'll go off to Google and say, I want this data. He'll bring it back to us, and then we can just download the data. So that was a bit of an awful analogy, but off we go. The four modules we're going to need here is pandas as PD. We're going to need import pandas underscore data reader dot data as web. We're also going to import matplotlib lib.pyplot as PLT, and the last one is import datetime. So datetime is a core Python library. We didn't have to import anything. This comes with Python. There's a couple of ones like that, and it's mainly concerned with the datetime object, which is a nicer way of kind of specifying time and dates. So it just makes things faster and makes things nicer, and some Python functions and whatever need it to work. So we're actually going to do this in the form of a function because we want to be kind of generalizing things, and if you want to generalize something, one of the best ways to do that is with a function. So we're going to be calling this function stock price graph, and we're going to be inputting a symbol, and then we're going to finish this definition, and then we're going to need so the function that we're interested in, which is the data reader function, needs 4 inputs: the symbol of the data we want it, with the API which we're going to be scraping it from, the start date and the end date. And the start date and the end date have to be in the datetime format. So the first thing we're going to have to do is come up with those kind of objects and formats. So this is going to look a little bit weird, but because it's the datetime library and it's the datetime function, so that looks a little bit weird. You can fix this by doing from datetime import datetime, but I would encourage not doing this because that just looks bad. Although this doesn't really look any better. It's a little bit hard, but yeah, just do what you feel is more comfortable. And we're going to be looking at this from the year 2016, from the 1st of January, and we're going to be going to, I'm just going to copy and paste this because I'm lazy, we're going to be going to 2017, 1st of January. So those are our start and end dates. We are going to then get the data, so we're going to say data equals web.dataReader, and then make sure you got the capitals there. We're going to take the symbol, using our dummy variable symbol. We're going to say we want it from Google. We can also choose Yahoo, but Google is all we need for what we're doing today. We're going to have the start and end date be the start and end date which we have up here, and then we're going to come down. So that's our data. So now we have the data imported. Then what we need to do is do plt.plot, and then we are going to be plotting the index of our data, which is going to come out as time, and then we are going to be plotting the open column of our data. So this might look a little bit weird, and what I'm actually going to do here after showing the plot is come back up here and then get it to print the data.head so we can see what's going on behind the scenes for now. So after this function is declared, I'm going to run the stock price graph. That didn't give me enough. Let's do stock. There we go. And we are going to be running it with AAPL, which is the stock symbol for Apple. So if we do this, we should get, oh dear, data reader. That's not it. It's data reader. There we go. There we go, a helpful error. So here we can see we have our nice graph here of the stock price of Apple. It goes up and down, as you'd expect a stock price to go, but we can also here see what the API gives us. So the API gives us, through pandas, it gives us the dates in the indexes, it gives us the open price, the high price, the low price, the close price, and the volume of stocks that were, I think it's the trading volume in terms of how many were passed around. I'm not sure if it's, yeah, because I'm not a financial person, but I think that's the amount of stock which was traded, and these are the prices at which they were traded at. So we're just looking at the open price. So every day the stock market will open, and that's the open price, and then at the end it'll be the close price. So we can see here that these are going to be quite similar, and these are going to be quite similar. There is some movement between them. I think that's an answer from a finance person should answer. But yeah, this is when the stock market opens and closes, and then we have the highs and the lows. We don't really want to be graphing these for now because those aren't really reliable data in a sense, because these can vary, but the open and close are kind of like the standards. So the extension for this, which is going to be the mini project for this kind of video, is we're going to be editing this code here, but we're going to be printing the mean and variance for the stock along with the graph. So I want you to edit this and kind of get the mean and the variance, which is kind of like pretty straightforward. Show the value of the mean as a line on the graph. So this will be a very straight line, which isn't going to be very helpful. But then we're going to make this more helpful by creating a new column in the data frame, and then making that a moving average of the stock over the last 5 days or dates. And then we're going to be graphing that moving average. So this is going to create a line that will go like this, and it'll kind of weave through the data, which will give us some kind of, it'll be a lot smoother. And then the other thing you're going to want to do is you're going to want to do the same thing but with 25 dates instead of 5. And then you're going to want to graph that on the graph. So what this graph will end up being is your actual stock data, the 5-day moving average and the 25-day moving average. And then by theory, and I'll hope this works, when the lines of the 5 and the 25 moving averages cross, something should happen on the graph. And that's a form of actual analysis that they'll actually use in real life, which is quite interesting and quite simple to do. So I hope you've enjoyed this video, and I'll see you next time.